Copper has been used by humans for thousands of years because of its unique physical properties. It conducts heat efficiently, resists corrosion, and can be reused again and again without losing its quality. In modern infrastructure, copper wire plays a critical role. It runs through residential buildings, factories, power systems, and industrial machinery. As these systems age or are replaced, large quantities of copper wire are left behind. Rather than becoming waste, this discarded material begins a new industrial journey. The process starts with the collection of old copper wire from construction sites, demolished structures, factories, and obsolete electrical systems, where tons of used wire are gathered and transported to recycling facilities for further processing. Once inside the facility, the copper wire is unloaded and sorted according to thickness and condition. At this stage, the metal is still covered with plastic insulation and mixed with dust, oil residue, and other contaminants. Specialized machines or manual processes are used to strip away the insulation, separating the copper from non-metal materials. This step is essential as even small impurities can affect the quality of the final product. After the insulation has been removed, the exposed copper undergoes a thorough cleaning process. Mechanical brushing, washing, and controlled chemical treatments are applied to eliminate dust, oil residues, oxidation, and remaining contaminants on the metal surface. This cleaning stage is critical for maintaining material purity. Once cleaned, the copper is inspected and tested to verify its composition and condition. Any pieces containing foreign metals or structural defects are separated and removed. Only copper that meets industrial purity standards proceeds to the next stage. Once the copper has been cleaned and approved for processing, it is prepared for metallurgical treatment. The wire is cut into uniformly sized segments to ensure predictable thermal behavior during melting. Reducing the material to controlled dimensions allows heat to penetrate evenly, preventing localized overheating or incomplete melting. Each batch is weighed, recorded, and organized according to furnace capacity, ensuring consistent processing conditions and stable material quality throughout production. The prepared copper segments are introduced into high-temperature furnaces designed for non-ferrous metal processing. As furnace temperatures rise beyond 1,000 degrees Celsius, thermal energy gradually breaks down the metallic structure, transforming solid copper into a molten state. During this phase, differences in density and melting behavior cause remaining impurities to separate from the molten copper. Oxides and foreign materials rise to the surface as slag, which is systematically removed to improve metal purity. This refining process is essential for producing copper with high thermal conductivity, structural consistency, and long-term durability, all of which are critical for cooking applications. Once refining is complete, the molten copper is transferred to casting stations and poured into large molds. These molds define the initial geometry, wall thickness, and overall volume of the cooking pots. The controlled cooling process allows the molten copper to solidify gradually, reducing internal stress and preventing structural defects. This stage establishes the metallurgical foundation that will support subsequent mechanical shaping and finishing operations. After solidification, the rough copper castings are removed from the molds and undergo mechanical forming. Industrial presses, rolling equipment, and manual hammering are applied to refine the pot's shape and dimensions. This controlled deformation process compresses the metal structure, increases density, and enhances heat distribution across the surface of the pot. Each forming step is carefully monitored to maintain uniform thickness and structural balance. Once the internal structure has been stabilized, the copper pots move into fine machining and functional adjustment. At this stage, thickness uniformity across the basin walls is carefully checked and corrected if necessary. The base of the pot may be flattened or reinforced to ensure even contact with heat sources. This step improves heat transfer efficiency and prevents uneven cooking during operation. Functional accuracy is essential, especially for large-scale cooking pots designed for commercial or industrial kitchens. With structural and functional adjustments complete, the copper pots undergo final surface finishing. Polishing removes surface irregularities, enhances corrosion resistance, and improves visual quality. The rim, handles, and base are refined, followed by a final inspection to verify dimensions, surface quality, and overall performance. Only pots that meet strict industrial standards are approved for use. At first glance, these old copper wires look like industrial waste. They are tangled, oxidized, uneven in thickness, and no longer suitable for electrical use. But beneath the darkened surface, the copper itself remains highly conductive, dense, and valuable. This is where the process begins, not with something new, but with something forgotten. The final surface is cleaned, polished, and inspected. Each pot is unique, shaped by recycled material and human hands. No two are exactly the same. This process is not about speed. It is about control, patience, and respect for material. Old copper does not disappear. It transforms.